Okay, in this video I'm going to do a couple more examples of the product rule and quotient rule. These examples hopefully will help you guys get it more embedded in your head. There will be a total of 4 examples. The first 3 will be on this video and the last one will be on the last video because the last one's a little bit longer. So let's go ahead and get started. So we have some kind of function here, f of x, and we know that f of x is a product of 2 functions, square root of x and the natural log of x. So since they're multiplied times each other, we're going to go ahead and use the product rule. And if you guys remember from my last video, the product rule states that f prime of x of 2 functions multiplied together is equal to f prime g plus f g prime. So I already, as you can see here, labeled a function f is the square root of x, and I already labeled a function g as the natural log of x. So now all we have to do is find out what f prime and g prime are, and we can just plug it back into this equation and get an answer. So what I'm going to do here is we're going to have f, like I said before, f is going to be equal to square root x, g is going to be equal to the natural log of x, and f prime, so we have f prime is going to be equal to 1/2 x to the negative 1/2. Now, if you're having a question on where I got this from, if you remember your square root and exponent rules, that the square root of x is actually x to the 1/2. And then if we use our exponent rule for derivatives, we simply multiply this 1/2 out and subtract 1. So then the derivative is 1/2 x to the negative 1/2, which is where I got my answer. So g prime is simply just 1 over x. That's just a simple memorization rule from natural log of x to 1 over x. And now all we do is plug everything back in. So we have f prime of x is going to be equal to f prime, which is 1/2 x to the negative 1/2, times g, which we said was natural log of x, plus f, which is the square root of x, g prime, which is 1 over x, and if we want to simplify that answer just to make this x be a denominator of this entire thing, our final answer will be f prime of x equals 1/2 x to the negative 1/2, 2 a little better, times the natural log of x plus square root of x all over x. Simple enough. So another recap, we just stated, we looked at the function, determined that it was a product of 2 functions, wrote our product rule, defined our f and g, we defined it again down here, solved for f prime and g prime, plugged it back in, and got an answer. Simple as that. Alright, so let's go ahead and look at our next example. So our next example, we have f of x equals 2x minus 1 all over x squared. Now, if we look here, we see that we have a function on top, 2x minus 1, divided by a function on the bottom, x squared. Since we know this is a divided by sign here, we know we're going to use the quotient rule. If you recall, the quotient rule is simply this. We have, I'm going to write it up here so I have a little bit of space to work the problem. F prime of x is equal to f prime g minus f g prime all over g squared. So we have that function there, and we have the derivative. So all we need to do is determine what f, g, g prime, and g squared are, and we can solve for our derivative. So I'm going to go ahead and label this top function f, and I'm going to go ahead and label this bottom function g. Now don't get confused, this isn't multiplied by, I'm just labeling this is g and this is f. So we do a similar thing. We come down here and restate what we've labeled. We say f equals 2x minus 1. We say that g equals x squared. We go ahead and say f prime, the derivative of f, is simply just equal to 2, because the derivative of a constant is 0. Derivative of 2x is just 2. And then we have g, so we know g prime is simply just 2x. We notice that here because the derivative of g, which is x squared, is simply just 2x. And we need one more term now for this. We need g squared. So we know g squared, and I'm going to go ahead and write that here, is just x squared squared. So for simple terms now, I'll just leave it as x squared squared. So now we have all the things we need. We just plug it back into our derivative formula. So we have f prime of x equals f prime, which we said was 2, times g, which we said was x squared, minus the quantity of f, which is 2x minus 1, g prime, which you said was 2x, all over g squared. G squared is simply x squared squared. Now, depending on how far you want to go with this or how far your professor wants it, this answer is 100% completely correct. If your professor specifically states write it in simplest terms, then you're obviously going to have to distribute the 2x and this square term here. But if it just says find the derivative, this is the base answer, and this would be our final answer. Notice, like I always say, same process. We write out our function, we write out what our derivative equation is, we label a function f and g, we find out what the derivatives of f and g are, and in some cases, like with the quotient rule, g squared, and erase that there, and we simply just take that and plug it back into our formula and get an answer. Alright, so let's go ahead and look at the next example. Whew. Thank you, Jesus, for that. Thank you, Lord. Alright. So our next example will be a little bit more involved, but not too much. So we have f of x is equal to 8x cubed, all divided by 9 plus x squared. Divided by 9 plus x squared. Okay, and just to make that a little neater for you guys, there we go. So, similar process, you could probably say word for word what I'm about to say. We see that we have a function on top divided by another function on the bottom. We're going to have to use the quotient rule. So we know that the rule for the quotient rule is that f prime of x is equal to f prime g plus f g prime all over g squared. So I'm going to go ahead and label the top function f, the bottom function g, and we go ahead and account for everything down here. So we have f prime equals, I'm sorry, just f. F equals, like we said up here, 8x cubed. We have f prime, another simple power rule, 24x squared. We have g, which we said was 9 plus x squared, and g prime, which again, just derivative of constant 0, derivative of x squared 2x, so we know g prime is going to be 2x. Now g squared is simply going to be just that. G squared equals 9 plus x squared squared. Alright, we have all the elements. We just plug it back into our equation. So we know that equals f prime g, oops, and I'm sorry, this should not be a plus up here. It should be a subtraction sign for the derivative equation. So we know that f prime of x equals f prime g minus f g prime, all divided by g squared. So we have 24 x squared times g, which we say is 9 plus x squared. So times 9 plus x squared minus quantity of f, which is 8x cubed, g prime times 2x, all divided by g squared, which we said was 9 plus x squared. 9 plus x squared squared. So once again, like I said in the last problem, if your professor wants it in its most simplest terms, you're obviously going to have to distribute the 24x squared and, you know, distribute this 2x and distribute this square here. But if they don't, this answer is perfectly fine. We have f prime of x is equal to this expression right here. Alrighty, there's our 3 examples. In the next video, I'm going to do quite a bit longer example. It's going to be more simpler than these, so it's not just going to be a function divided by a function. It's going to have multiple terms, and we're going to use both the sum rule, that the derivative of an expression that's made of elements that are summed together is equal to the derivative of each sum added together. We're going to do that, and it's going to take a long time, but it's going to be a combination of that along with our product and quotient rules, so that you guys get a full feeling of what something on your exam may feel like. Thank you for your time.